Hello, and welcome to ServiceNow's Low-Code Capability Deep Dive. In this 9-part series, we're going to take a look at the various aspects of the ServiceNow platform that empower creators of all skill levels with the ability to rapidly build high-quality, scalable, and easy-to-govern apps. In this 9-part series, we're going to take a look at the various aspects of the ServiceNow platform that empower creators of all skill levels with the ability to rapidly build high-quality, scalable, and easy-to-govern apps.
In this application and data connectivity section, I will describe how ServiceNow integrates with external systems. The topics covered include API creation, authentication, management and monitoring, data import, and transformation and data virtualization, RPA bot management, and our connectors for popular LLMs such as OpenAI, Gemini, Llama, and more. This section begins with one of the foundations of integration in ServiceNow: connections and credentials. Connections and credentials is centralized on the ServiceNow platform to allow platform administrators to create and distribute credentials to developers without exposing passwords and secret keys. Credentials can then be used by developers in a curated way, which reduces the risk of misconfiguration, which can cause security issues. This approach allows low-code developers to enhance their applications, workflows, and automations with external data in a safe and secure way without having to involve pro coders. Workflow Studio integrates workflow and integration authoring, configuring, and monitoring into a single experience. Playbooks, flows, actions, data streams, and decisions can all be created from a single development environment. Operational data is available to platform administrators and process owners, such as flow execution metrics, including errors and long-running flows. On the Integrations tab, all installed out of the box and custom created connections and their statuses is shown so that administrators can configure them for use in applications and workflows. There are numerous out-of-the-box integration spokes which allow ServiceNow to connect to external systems. These spokes are authored by vendors themselves or in collaboration with ServiceNow. The ServiceNow store hosts these spokes, which can be easily installed into customers' instances. Often, spokes only require a credential and connection to be defined before they begin used in workflows. This minimal setup approach means that low-code developers can leverage integrations without being exposed to the complexity of developing one themselves. Developers need only understand the inputs required and how to use the output data to enhance their workflows. Where an out-of-the-box integration for a system is not available, custom actions can be created. Setting up an action is a low-code experience by defining inputs, outputs, and wiring them up to steps using data pills. Configuring integration steps is simplified by selecting existing connections and credentials, and even importing API specifications through OpenAPI documentation. This example shows an integration with the Stripe payments platform to create a payment intent. The connection and credential has already been set up by my platform administrator, and the REST API operations have been imported using Stripe's OpenAPI spec. When I select the payment intent operation, it automatically creates inputs and outputs based on the API query parameters and return object. Once published, this action is ready to be used in my flow, and other developers benefit from not having to define this integration again, and can reuse this action in their flows too. Data streams are special actions which automatically handle pagination and query limits when requesting large lists of data from APIs. In this data stream, I am requesting a list of all payments made to my Stripe account. Data streams need 3 additional variables configured on top of normal actions. The page size determines how many results to return each time. The getNextPage determines if we've reached the end of the stream, and an optional parameter for the page we are currently requesting. Once configured, data streams can be used in flows, but are most commonly used for regular importing of data into ServiceNow. There are a number of different ways to import data into ServiceNow. By using Integration Hub imports, this process is streamlined as developers leverage integration spokes and transform mapping to bring data into ServiceNow. Let's take a look at the connection to retrieve tenant information from an Azure SQL database. This import leverages a custom data stream connection to my company's tenant database. Retrieved fields can be seen here on the right-hand side, which are then mapped to fields in my custom property management application table. Data can be transformed before insertion and coalesced against existing contact information to ensure no duplicate records are created. Imports can then be scheduled to run, and execution results are logged for debugging or audit purposes. Scripted REST APIs are one way developers can create custom inbound endpoints. Scripted REST APIs give external systems access into ServiceNow resources, such as custom application data and workflows. Here is an example of a scripted REST API. Actions, parameters, responses, and resource paths can all be configured with no code. The API response is scripted by using ServiceNow inbuilt scripting APIs to query and collate or mutate data or execute workflows. Default authentication is handled by the platform and can be customized, and API analytics are collected automatically without any additional setup. A low-code alternative to the scripted REST API is the Table API. The Table API can be used to access data in any ServiceNow table, including custom tables created by developers. Authentication is required and security respects existing table access controls. Pagination is standard, and the output response can be formatted in JSON or XML. The interface you see here is REST API Explorer. Here, developers can find API documentation and example code samples for every REST API on the platform. APIs created for custom applications are also included, and documentation created automatically for the developer. An open API specification is available for download so that developers and external systems can learn how to use the APIs. So far, I've been showing integrations into external systems running over the open internet. If customers want to connect ServiceNow to internal resources behind firewalls or on-premise local networks, they can do so by installing a MID server on a local machine. The MID server is a client agent which queries ServiceNow for work. Both inbound and outbound integrations can run through a MID server, connecting ServiceNow to offline customer resources. Remote tables are a form of data virtualization that presents external data as native ServiceNow tables. Remote tables differ from data imports because results are temporarily stored in system memory as opposed to persisted in a table. Remote tables present just like any other data, with native lists and forms, and can be queried using standard platform condition builder or scripting APIs. ERP Canvas simplifies connecting ServiceNow to ERPs so that low-code developers can build powerful applications and workflows enriched with ERP data. ERP Canvas leverages remote tables for an on-demand lookups and extraction tables for persisting and updating ERP records in ServiceNow. The ERP Canvas displays a list of ERP models, their ERP source tables, fields, and how the ERP tables are joined. Remote table integrations and extraction table transforms are automatically configured from these models. The ERP Systems tab shows connection health back to the ERP system. Developers can build automations directly by including ERP Canvas tables in their workflows. This is an example of a scheduled flow checking when stock counts were last updated, and raising a request if they haven't been updated in the last 4 weeks. ServiceNow provides a common Generative AI Controller for use with several different AI platforms, such as Azure OpenAI, Google AI Studio, OpenAI, and IBM watsonx. The Generative AI Controller presents AI capabilities in playbooks, virtual agent, scripts, and workflows. Sentiment analysis, summarization, generate content, and generic prompting skills can all be used by low-code developers. Here is an example of a simple yet powerful use of the summarization skill. I have created a flow which summarizes the description of an incident and updates the short description field. The generic prompt action can be used to create one-shot prompts. For example, this flow instructs the AI to act as a Scrum Master and generate acceptance criteria from a story description.
Thanks for watching, and join us for part 5 of our series as we explore application testing.